Alright, in this video we're going to look at using Excel to help us get through this crazy looking formula. So we got x's, y's, x squareds, all this stuff, and we're going to use Excel to help navigate through it a little bit quicker. So let's look at the data set. So this was the data set I gave you in the notes example, so I'm going to throw this into Excel real quick. Now in the video I showed you the correlation shortcut that you can use, which was click there, highlight your x's, comma, highlight your y's, and there's your correlation coefficient. Okay, but just to kind of show you, this is the expectation of what you're going to do in the view and example is you're going to make all of these. So I'm going to go up here and let me stick in a label column. So this is the x's, this is the y's. And I'm going to do just like this. I'm going to make an xy because I need that in the formula. I'm going to make the x squared and I'm going to make the y squared column. Alright, and I'm going to do exactly what each of these columns says. This says multiplies the x and the y's together. So I'm going to write equals this x times this y, and then I'm going to click in that cell, double click the little the block in the bottom right corner, and it multiplies all the columns all the way down. Right, and you notice we get all these same numbers. Okay, I do need to add these up. I'm going to go ahead and add it. So you can just click up here in the upper right corner, the sum button. You can click that and it'll add everything. Alright, so I'm going to do the same for the y's and the x's. And you should probably make yourself a little note by like putting them in like, you know, a color there that those are the sums. I'm going to color these two as well because they'll end up being sums. Alright, and then this is the x squared. So I'm just in that cell, I'm going to type equals. I'm going to click this. I'm going to say square. And I'm going to click, and this time instead of double click, I'm just going to drag down. Alright, so there's all the x's squared, and I'm going to add those up. And then the same thing for y's. Equals the y squared this time. So here's the y. So click that. Shift 6 to the second power. Click, drag down. Alright, they're highlighted sum. Alright, and now I've got the sum of the x's, the sum of the y's, the sum of xy's, 12.35, the sum of the x squareds, and the sum of the y squareds. Alright, now I'm going to get the formula, and it is, I'm going to type R right here, R, and then R equals, and I got to write all of this stuff. Now all of this is in the numerator over here on this side, so I need a parentheses around all this on the left, because there's a lot of stuff going on. Then I will need a parentheses around all this and the denominator because there's a multiplication symbol going on right there. Alright, so let's go back over here. R equals, what does R equal? Parentheses. N. Alright, N is the number of data points we have. So we could either count it by hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, 10 times. Or literally we could use the count feature that you've seen before in here. But there's not a very much big data set. It's easy to count it. Now, the sum of x times y. That's right here. Alright, minus the sum of x. The sum of x times the sum of y. Now, there's not a times dot there, but I have to do it still. Because anytime you multiply in Excel, you have to show it. Alright, and then close the parentheses. Divided by parentheses, because we're doing a division that has multiplication at the bottom. Alright, square root, remember that's SQRT. I'll double click that. Square root of what? N, which again was 10. 10 times the sum of x squared minus the sum of x squared. The sum of x, and then shift 6 squared. Alright, that ends that square root. So notice I haven't ended it yet. I have to use parentheses. I've ended that parentheses, which was the square root, but I haven't ended that one yet. So I'm done with that. Now I'm going to this. Alright, so that's times another square root, so another sqrt, double click. Alright, n again, so it's 10 times the sum of the y's, so the sum of the y's squareds, right, minus the sum of the y's, squared. Okay, and in that parentheses. Alright, and then there, oops, I left off the parentheses. And then there's that r equals 0.95. Now notice right there, that's what I left off. I had it like that, which ended that square root, but I didn't end the entire denominator, so that's why I made that beeping sound. Alright, so there's the same thing, and then watch this. Equals Correl. Where's your x's? They're right here. Comma, where's your y's? They're right here. Enter. Same thing. Alright, so you can either do that, or you can do this. Okay, it's fine with me if you do this. Okay, I do want you to see the formula and see that we are literally measuring how an x and y are related. And notice there's x's and y's all over the place to measure this relationship. But it's completely fine with me if you just use this correlation shortcut in Excel. I want you to know this part. And there's a lot of questions in the homework where you're just kind of matching correlation to the scatter plots. But this is what I want you to know. I want you to be able to, if the correlation is negative 0.9215, I want you to know it's more like this than it is like this, or this, or this. You know, I want you to be able to kind of visualize how tight the data is in a downward sloping line. Alright, here's a homework problem, just straight from your homework. So in this one, it's asking us to do the same thing, compute R, come up with what R is. So this one has a little, when you see a data set like this in your homework and you see this little rectangle, one of the things it does, one of the options is copy to clipboard or even open in Excel. If you open in Excel, I believe, I'm not 100% certain, but I think it will download, yeah, it downloads an Excel file. I would just copy it to a clipboard and then Control C, and then put that thing over here. And then over here you can, well, the way you'd handle Excel, I didn't realize it would not just paste it the way it's supposed to be. But the way you would handle that is you would go to Data, Text to Columns, and then right here, delimited, and you would hit Next and tell it it is a comma, and then hit Finish. Alright, now it's got everything separated, or you could just download the Excel file. That's probably would have been easier. Just do that. It downloaded the Excel file right here. I can show it to you. Right there. So I click that. So it opens it in Excel, and there's everything. I'll click Enable Editing, and now I have access to it. Okay. And they want us to come up with the correlation coefficient. So once again, I would just click equals COR correlation. Click that. Here's my first. Alright, comma, and then here is the other one. Enter. So 0.988 or 989 roughly. How many places do they want it? Oops. They want it to 2 decimal places. So 0.99. Alright, so that's a way you can use Excel in this little shortcut thing. Again, I would click Open in Excel rather than copy to clipboard, because you don't have to go through all that stuff to separate it for the commas. But that's a way you can use Excel to come up with this correlation values really fast. Alright, and then this last type of question that you'll see in the homework. This is getting into pretty advanced statistics. This is called a hypothesis test. And what we have to remember is one of those things from our notes said that correlation, when we see correlation, one of the things says here, correlation could simply just be a coincidence. And that's because we're sampling. We're taking a sample of a bigger population. And when we have a big population and we take a really tiny sample, just by a freak random occurrence, we could get data that lines up in a perfect straight line and it shouldn't have. You know, in the population it never would have. It's just a randomly random thing that happened where our sample just happened to line up in that line, but nothing else would. You know, if we did it again 100 million times, it would never happen again. Okay, that's what this idea is. So what this alpha is, this is like a 5% probability. So this is like the probability that what we're seeing is like a freak accident, that it really wouldn't happen normally. So what we do with this is we look at the sample size. So the sample size is 9. So we come down here and we find 9. And this is what R would need to be higher than for us to say that there really is a correlation in the population. Because there is a 5% chance that if our sample size is only 9, that we could see, we could see a freak occurrence just because that's such a small sample size that would suggest that there is a correlation in the population, even when there's not. So we have a pretty high standard. Of course, we pick the one at random that gives us 0.666. But what we do with this, we find the sample size, we find that this is called the critical correlation coefficient. And what that means is R in the sample has to be bigger than this for us to say a correlation exists. So the correlation coefficient is 0.57. Sample size is 9. So I find this 9. I see the 0.666. R needs to be bigger than that. Well, 0.5 is not bigger than 0.6. So there is no correlation here in the population. Alright, now if I do it again, let's see what it gives me this time. R equals 0.62. N equals 22. So here's N equals 22. Now because my sample size is much bigger, notice as the sample size gets bigger, the critical R goes down, 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 down. So R equals 0.62, N equals 22. I only have to be bigger than 0.423. I am bigger than 0.4. 0.6 is bigger than 0.4. So there is a correlation. I should say, there is a very good chance that there is a correlation that exists in the population. Okay, this is in the population. Obviously, that's suggesting there's a correlation in the sample. But we're talking about the entire population, not just the 22 people we sampled from the population. Okay, think about the entire state of North Carolina, and you pick 22 people. Okay, just by a freak chance, the 22 that you get could show something that the rest of the population doesn't have. So this data, this table over here, is trying to show you that what we have to surpass to suggest that there is a correlation. As soon as we find this right sample size, this is a number we have to be bigger than in absolute value. So if this was negative, it would still be fine. It has to be bigger than this in absolute value for us to say there's a correlation in the population. Alright, and here is one that has a negative. I wanted you to see that. So 17, there's 17. We have to be bigger in absolute value than 0.482. Right? Remember, 0.48 absolute value means just ignore the negative. Here, just look at the number. So 0.69 is bigger than 0.482. So we conclude that a correlation does exist in the population.